Okay, so this is problem 6.7.49, and we're asked to solve, and we're given this equation right here. Okay, so remember, when we're solving rational expressions, or rational equations, excuse me, we're first of all needing to factor all of the denominators fully. So we see the difference of squares here in this denominator. And the reason for factoring the denominators is so that we can identify what the LCM is. And the LCM in this problem is going to end up being y minus 2 and y plus 2. So remember, you're looking at each factor and deciding on how many times does it occur the most in any one factorization, so any of the denominators, and that's how many times you'll need it in the LCM. So y minus 2 occurs once here, it occurs once here, and it occurs no times there. So the most it occurs in any of these spots is once, so we'll need it once. And then the y plus 2 occurs one time here, no times there, so the most that we see it in any spot is once. Okay, so once you've identified that LCM, what we're going to do is we're actually going to multiply everything in the problem by the LCM, and that's so that we can clear the fraction. Okay, and I encourage you to write this out because it will prevent mistakes. So each of these is getting multiplied by the y minus 2, y plus 2. Okay, it's a little small there, but I'm running out of room. Okay, so that's y minus 2 and y plus 2 right there. Okay. All right, so we can do some canceling then. We see y minus 2 is canceling here, and we're left with 6 times y plus 2. So that's this 6, and we're going to need to multiply that by that whole quantity, which is why I have I'm showing this in parentheses here. Okay, and then here both the y minus 2 and y plus 2's are going to cancel. We need to pay attention to the fact that there's a minus sign out here, and so we're subtracting this whole 5y minus 6. So again, we're going to need to have parentheses here so that we'll remember to distribute the negative in the next step. And here the y plus 2's are going to cancel, and so we're left with 3 times the y minus 2. Okay, so at this point, we're solving. The fraction is gone, and we're just going to do a basic solve. So we're going to need to distribute the 6, distribute the negative 1, and distribute the 3. So we're going to have 6y plus 12. This is minus 5y plus 6, and then 3y minus 6. Okay, this is linear, so when I say linear, I mean the highest power that I see on the variable is a 1. So that means we're just going to try and get all of our variables on one side and the constants on the other side. And so if I go ahead and collect like terms on this side first, the 6y and the minus 5y is just a positive y. And then we have 12 and 6 is going to be 18. And that's equal to the 3y minus 6. Okay, so all right, so now we're going to get our y's together. So I'm going to go ahead and take this y to that side, and I'm going to bring the 6 over as well. So I'm seeing 24 equal to 2y, and then divide by 2, and we find that y here equals 12. Now we need to, before we can call that a solution, we need to check it, and the thing that we're trying to check is to make sure that it does not give us 0 in any of our denominators. So if we look at our denominators here, I see that if I plug in 12 here, I would get 12 minus 2, that would be 10, that's fine. And here 12 plus 2, that would be 14, that's fine. So y equals 12 would be a solution here. The two values that you can't have in this problem would be a positive 2 and a negative 2. Those values would actually zero us out in the denominator, and that's undefined. Okay, but y equals 12 does work, so that would be our solution in this problem.